Hey everybody, Mr. Reeves with you today, and I am here to work through some problems on IXL. Specifically, I'm going to start with the 8th grade F12 skill evaluating expressions using properties of exponents. Okay, so we're going to be using the properties of exponents we know to arrive at these answers. So right here we have 2 to the second times 2 to the second, which of course would be 2 to the fourth power. But if you put 2 to the fourth power in, as I will do right now, 2 to the fourth power, then you will see that it says sorry, incorrect, and the correct answer is 16. Now, if you're thinking, well, wait, 2 to the fourth power is 16, you're absolutely correct. But notice the directions say evaluate, which means write your answer as a number answer. It doesn't say write your answer as a power. All right, so for example, on this one, again, 6 to the 5th over 6 to the 3rd. If I were doing this right here, it would be 6 to the 5 minus 3, which is 2. 6 to the 2nd power. But I'm not going to put that. I learned my lesson, and instead I'm going to put 36. Okay, so now I can see 6 to the 3rd power is 36. All right. Right here, I'm going to have 4 to the 2nd times 4 to the 2nd, which is going to be 4 to the 4th power. 4 times 4 is 16 times 4 is 64 times 4 is 256. Again, this one right here, 9 to the 6th power divided by 9 to the 4th power, I would subtract, and that would be 9 to the 2nd power, or 81. Okay, so if it's a multiplication problem, we're going to add the exponents. If it's a division problem, we're going to subtract the exponents. And if it's a raising to a power problem, we're going to multiply. All right, let's go ahead and jump up to the next level and see what they have for us. Oh, now it's a little bit tricky here because now the bases are not the same, and you'll notice the exponents are not the same. So if you're looking for a rule to apply to this, you're not going to be able to. All right, so there is no way to combine these unless you change the bases to be the same, or if somehow we could make the powers the same. All right, so what we're going to do instead is we're going to say 6 to the 2nd power is 36. All right, and 3 to the 3rd power, 3 to the 3rd power, 3 times 3 times 3 is 27, right? So what we have to do is we have to do 36 times 27, all right? Now we can do this by hand, and I expect you to be able to do it by hand, but at this point, I really don't mind if you get out a calculator and use a calculator, as long as you know that 6 squared is 36 and 3 to the 3rd is 27. All right, so I'm going to go ahead and get out my calculator, and I'm going to do 36 times 27, and it's going to tell me that the answer is 972. Okay? Again, we don't want to just be typing the answer in to a calculator from the beginning, but if once you know the properties of exponents and you get some really big numbers, it's okay to use a calculator. Again, this one, 4 to the 2nd times 4 to the 2nd, you should know is 4 to the 4th power, which we said was 256. All right, now again, these bases are not the same, right? So we need to know, all right, that 12 squared divided by 6 squared. Now we actually have an option here because the exponents are the same. So 12 squared over 6 squared, we could write this way. We could write it as 12 over 6 squared. We learned earlier that we can distribute that exponent, right? In that case, we could do what's inside the parentheses and get 12 divided by 6 and get 2 squared is equal to 4. So that's one way to do it. Another way to do it would be to say 12 squared is 144, and say that 6 squared is 36, and then divide 144 by 36 and get 4 that way. Either way is correct. Either way gets you the correct answer of 4. All right? Okay, and again here the bases are the same. So 5 to the 8th divided by 5 to the 5th, that would be 5 to the 3rd power, which is going to be 5 times 5 times 5. I hope you don't need a calculator for that one to know that that is 125. All right, let's skip over to the next level and see what's going on here. All right, well, this one isn't any more difficult. 5 to the 9th over 5 to the 8th is going to be 5 to the 1st power, right? Or just 5. Awesome. Okay, oh, now it's getting a little more tricky, okay? Because now we have a negative exponent right here. All right, quick reminder about negative exponents. N to the negative, actually, let me do this, sorry. Let's do just a reminder like this. 4 to the negative 2 is 1 over 4 to the 2nd power, right? And anytime you have a number, you could put it over 1 if you want it to be a fraction. So I've said it before, I'm going to say it again. A negative exponent in the numerator becomes a positive exponent in the denominator, right? And you can't leave the top empty, okay, like that, so we could put a 1 there. If I had 1 over 4 to the negative 2, then that would become 4 to the positive 2 over 1. Okay? So if you are given, sorry, like that. If you're given 8 to the negative 6 here, and you see how they made a fraction already for you, then you know you could put this 8 to the 6 down here. And this 8 to the 5th, both of these are really over 1 like that, okay? And this is right here is 8 to the 5th. So the 8 to the 5th is on the top, and the 8 to the negative 6 becomes 8 to the 6 on the bottom. All right, and now if we did this, we'd get 5 over, we have 8 to the 5th over 8 to the 6th, that's 8 to the negative 1, right? But 8 to the negative 1 is 1 over 8 to the 1st. So that's the answer that we are looking for. Now, I think I've told you before. If not, I'm going to tell you now. When you have bases that are the same, and you know that you don't want to have a negative exponent, you could ask yourself, where do I have more and how many more do I have? I have 8 to the 6th on the bottom and 8 to the 5th on the top. So where do I have more 8s? I have more 8s on the bottom. How many more do I have? I have 1. And you're never allowed to leave the top empty. All right, so however you approach it, you get 1 on the top and you get 8 on the bottom. All right, here's another one. Okay, I'm liking this, okay? So right here we have 5 to the negative 2, so I'm going to put that on the bottom and make it 5 to the positive 2. Again, we don't write it this way, but you could put it over 1. And then I have 3 to the negative 4, and I could put 3 to the positive 4 on the bottom, which leaves nothing on the top, so we would put a 1. All right, and what's that going to give us? That's going to give us a 1 over 25 times, and 3 to the 4th is 3 times 3 times 3 times 3, which is going to be 81. Okay, so again, this is an example where it's perfectly appropriate to get out your calculator, which I seem to have closed, so I'm going to have to open the calculator again. Sorry about the delay here. We want to do 25 times 81, 25 times 81, and when we do that, we get 2025. So we're looking for 1 on the top and 2025 on the bottom. Okay? Okay, in this case, here we go. 12 to the 0 is on the top, and that would be a 1, right? And that 2 to the negative 4 is on the bottom, so it's going to go to the top and become 2 to the positive 4. And then nothing's left on the bottom, so it's just a 1. So on the top we get 1 times, and 2 to the 4, 2 times 2 times 2 times 2 is 16. So you get 16 over 1. But we are allowed to leave the bottom empty, so we just put 16 as our answer. Whoops, not 156, 16. Okay? All right, is there another level? Here, let's jump up and see. Jumping to the next level. Okay, here we go. Now we've got 5 to the 5th times 5 to the negative 3rd times 5 to the negative 3rd. Well, the bases are all the same, so it's 5 to the 5 plus negative 3 plus negative 3. Okay, if I add all those together, I get 5 to the -1, right? Because -3 plus -3, those two give me -6, and -6 plus 5 is -1. Well, again, 5 to the -1 is going to be 1 over 5 to the +1, right? Because if you just have the term with known, and it's not part of a fraction, you could turn any integer or any power into a fraction by putting it over 1. So now we have the negative in the numerator. It goes to the bottom. So we get 1 over 5 to the 1, or just 1 over 5. Okay, 1 over 5. All right. This time there's no negatives. Okay, so we have 10 squared over 12 squared. So here's another case where we have two choices. If we have 10 squared over 12 squared, we could write it as 10 over 12 squared, right? Yeah, because they're both raised to the second power. And then we can simplify the inside part. Well, 10 doesn't go into 12, or 12 doesn't go into 10, but both of them are divisible by 2. So we get 5 over 6 squared, and 5 squared is 25, and 6 squared is 36. So that's certainly one way to do it. The other way would be to say, okay, well, 10 squared is 100, and 12 squared is 104. Whoops. 10 squared is 100, and 12 squared is 144. And then I could say, well, what do I know that goes into both of those? I can divide them both by 4, and 100 divided by 4 is 25, and 144 divided by 4 is 36. Here, let me write divide by 4, divide by 4. So either way, we get 25 over 36. All right, is there another level to jump up to? Or are we as high as we can go? Help. All right. Challenge zone. Here we go. We are in the challenge zone. All right. So on the top, right, we've got the top and we've got the bottom. On the top, we have 4 to the 2 plus -4 plus 0. And on the bottom, we have 4 to the first, right? Even though there's not an exponent there, it's a 1, because if it were 0, we'd have to put a 0. So on the top, we get 4 to the, well, 2 plus -4 is -2 plus 0 is -2. 4 to the -2 over 4 to the first. Okay, but again, remember what we said. If it's negative in the numerator, it goes down to the bottom. So on the bottom, I have 4 to the first times 4 to the second. And now the top is empty, so I put a 1. And then I get 1 over 4 to the third power, right? Because we're going to add those. But 4 to the third power is 64. So I get 1 over 64. All righty. Okay, what about this one? I've got on the top 3 to the 4th times 3 to the 8th. So that's going to be 3 to the 4 plus 8 on the top. And on the bottom, I have 3 to the 6 plus 8, right? But before I do that, actually, if we go back here, 3 to the 8th over 3 to the 8th is going to be 1. When you have a multiplication problem and you have the same thing on the top and the bottom, you can actually divide it out. So I could have done that, and then that would just give me 3 to the 4th over 3 to the 6th, which if we were doing the way I talked about, where do I have more 3's? I have more 3's on the bottom. How many more do I have? I have 2, and I could get 1/9 that way. So certainly that is one way you could do it. If you didn't realize that and you just plugged along, you would get 3 to the 12th over 3 to the 14th. And again, if you subtract, you get 3 to the -2, which is 1 over 3 squared, which is 1 over 9. Okay? There we go. Alrighty, and it just keeps going from there. Just remember, combine the top exponents and the bottom, and if you end up with negatives, a negative exponent on the top becomes positive on the bottom, and a negative exponent on the bottom becomes positive on the top. And remember, you don't actually have to get a score of 100. These ones in the 90s are all in the challenge zone, and you don't have to do the challenge zone unless you really want to be challenged. All right, that's it for 8th grade IXL Skill F12. Stay tuned for Skill F13, coming soon to a theater near you.